Hi, my name's Will Krosick, Scientific Services Manager at Chemical Computing Group. Today I'd like to show you how to generate 3D conformations for a database of small molecules and superpose them to a common core. Conformational databases are useful as input to docking or pharmacophore searching. So here we've got our data. It's held in the database viewer, a chemically aware spreadsheet. This 2D input came from an SD file that's been opened in Mo, but equally it could be smile strings. We've already washed and prepared this database so that we can clean and protonate our ligands. This is all covered in a separate video, so I'm going to skip over this and go right ahead to open the conformational search panel. This is a useful application for generating conformations of small molecules through to peptides, proteins, and larger systems like ternary complexes or DNA, RNA. At the top, we can decide what it is we want to explore the conformations of, whether that's a database or an individual molecule. We have options to handle portions of the molecule as a rigid body, perhaps useful if we're generating conformations of ternary complexes or maintaining secondary structure of peptides. The middle allows us to choose our methodology as well as the stopping criteria. We also have here the option to use the refined output as input to QM optimization. The lower portion of the panel allows us to set the energy window, which will set limits on the potential energy of the resulting conformations. I can also include explicit waters and or counterions as part of my search. Now, these default values are suitable for small molecule ligands. However, if I'm handling a larger system, like a peptide, RNA, or a large complex, this energy window value might want to be increased. With that in mind, I'll just go ahead and accept the defaults and hit OK to start the calculation. So in the background, we're running LowModeMD. This is a combination of MD and LowMode. It's applied to all of the ligands in the dataset. Although we're not doing today, the input could include cofactors. So LowModeMD is perturbing the molecular system along the low-frequency vibrational modes. First, Mo generates random initial atomic velocities with the kinetic energies concentrated on those low modes. It then performs NVT dynamics before the system gets minimized, and that process is repeated to sample for other minima. A key advantage is that it provides an efficient sampling of the conformational space using angle and dihedral-like motions, and for that reason, LowModeMD is recommended for both large and complex structures like protein loops and ternary complexes, but also detailed small molecule analysis. So our results appear here in the database viewer, but our molecules are no longer 2D. They now have their 3D coordinates, along with some useful descriptors such as the radius of gyration, chi, which is encoding the stereochemistry information, the potential energy, and the potential energy relative to the lowest energy conformation. Now that we have this database, we could use this as input to docking or pharmacophore searching, but for now, I'd just like to go ahead and browse so that we can inspect some of these conformations. Now, given that this is a congeneric series, it's going to be easier if we can visualize these when they're superposed to a common core. So what I'm going to do is I'm just going to send one of these to the main Mo window, and what I'll do then is just select core that's common to this particular series. And by the way, if I had a known active conformation of the ligand bound to a target of interest, I could equally superpose this database to the known active conformation by just selecting the atoms from the binding pocket. In either scenario, the application that we'll want to use is molecule superpose. So here at the top, we can decide what it is we want to superpose. At the bottom, we choose how we want to superpose them, whether it's by the selected atoms, smarts, or perhaps by similarity. So in this case, we're going to be superposing all entries from the mol field of our input database, and we're going to be using the selected atoms from the main Mo window. So I'll just click OK, and I'm going to overwrite the mol field, and then I'll just tidy up my view a little bit before selecting all of the molecules, and then we can send those to the main Mo window. And with that, it brings us to the end of today's session, where we generated 3D conformations for a database of congeneric 2D ligands and superposed them to a common core. Conformational databases are also useful as input for docking or pharmacophore searching. If you have any questions, please do reach out to us at support@chemcomp.com.